Okay, we're coming up. Good evening, all. I am actually feeling better than I have for the last few days. I was going to stream yesterday, but I ended up just not doing much of it. I mostly just worked on classwork. Like, I don't have classes starting until October. I just want to be ahead of it. So I might even be able to live stream while classes are going on. All right. So anyway, the last stream was a bit of a bust. I went down this incredibly obnoxious rabbit hole of trying to get QMU working, and I did, and then we just had like 5 other issues pop up. So I'm just gonna say to hell with that. We're just gonna try using the ROM monitor. So I haven't really done much between the streams. All right. Let me see here. So if I hit Windows and yeah, tilde, I can break into the ROM monitor and I can use this to examine memory, which at least can give me some idea of what's going on. So I know the kernel was supposed to load at 2000. That does look like actual valid stuff that I'd expect. So that might actually be the kernel loader. The biggest problem I've determined with this is that the program counter does not seem to point where it was in memory when we break into the debugger, which is kind of annoying. Like if I pull up the process registers, I hit R, it says, yeah, we're here, which may be correct, may not be. It may be I don't understand how the memory map on this system works, like, which is entirely possible. So let's take a look at our VM Linux file and let's see what we're working with here. All right, Linux. So we want Motorola. Oh, I have to add it to the path. So or do I not? Okay, no, I do have it. So obj dump, disassemble VM Linux. I want underscore start, because that should be where we are in the code. So the first instruction, it's yeah, that definitely doesn't look right. That definitely doesn't look like the code we're currently in. So let me confirm that I am loading where we are loading this to, because this does load into a different address than the FreeBSD kernel, which could have like a bunch of other issues. But let's just start with what we know. So if we want to read ELF, we want the headers from the VM Linux file because I want to see the entry point. Yeah, so the entry point address is 2000. And I don't think there's a load address. If BSD is doing anything sane, it would load the bootloader towards the end of memory, which actually makes sense. I gotta do a little math here. So BC, the built-in load point is 4,000. Yeah, is this? I divide you. Yeah, so it'd be loading it plus 4 megabytes, and that would actually explain why our jumbo kernel kind of blew up. Because I believe the minimum memory configuration for a NeXT system was, I believe it will boot with 8, but I think 16 is the actual physical minimum. Yeah, so I am actually feeling better today. Like, it's definitely, compared to the last week, I definitely feel like I have some energy, which is kind of an improvement. Okay, so we are loading into 2000. Let me look more at this. So if we look at a hex dump of VM Linux, that does not help me. Yeah, so that also looks completely different. So what loaded into 2000? Let's actually look at the bootloader code so I understand what's going on, because this is kind of like the first hurdle for doing anything useful. So if we open folder, And we go to stand. So here's our bootloader. So it's going to load L32. And this is just all the code for reading the headers because ELF is annoying like that. So copy the ELF. Let's look a little further down. Let's just see what else we can find. Let me see if I can remember what let me look up the registers for the Motorola 68000 because I do not know this platform as well as I know a lot of other ones. Okay, so those are the assembly ones. Stack pointer is SP. 7 addressing. Okay, so let's look at the registers and let's just see what they have to say. M is memory, so we just hit A and then we just dump these out. So these don't look like they've been initialized or anything. These look like they've just come right out of the bootloader and are basically good, quote unquote. All right. So let's go back to our boot.c file. Entry point. So it downloads the bootloader and then it reads the header. Yeah, so load of boot. Fortunately, I can put debugging code in this really easily if we need it. So what I kind of want to understand is, so copy kernel boot argument. Okay. So load of, okay, so that's getting the kernel, that's getting the command line from the boot monitor. So we're not actually there yet. So this is reading in the, so your dev pars. And then main returns? That doesn't seem right. So kernel loads, so the last thing it does is it sets entry and eSIM, which would be the kernel load address. Okay, so hold on. Let's rewatch the boot messages and let's just see where it's putting stuff right now. Okay, so we're entering at 400. So it's loading relative to OX 40, 400, 2000. That has to probably deal with the memory map of the next station. Let me see what let me see if I can find something else here. Next station physical memory map, because this is where we start getting into the weeds, so to speak. And my first search of Google kind of comes up blank. It says that physical okay, so the AI answer, which I don't trust, but it's consistent with what I know about Motorola 68000. It says the system memory starts at 00 and goes up. So I need a hex calculator. So Windows 1 do hex? It's been a while. Yes, it does do hex. Okay. So what is this in decimal? Just so I can see here. Okay. Equal. Oh, okay. There we go. Okay. So that would suggest that this is putting it at the upper end of... That doesn't seem right to me. Because our system memory, if it starts at 0, 0, our system memory is only... Hold on, there's an option in here to look at memory configuration. Let's take a look at that and tell me if I can understand what I'm working with. I am worried I may have bitten off slightly more than I can chew. Okay, here we go. There we go. So memory sockets 0 through 3 have... Okay, so they are mapped into... That's interesting. So what's mapped at 0, 0 then, if anything? Because this is telling me that there's parity RAM installed at OX 4 million, or hold on, I can do math. I can math. Hold on. Yeah. So it is mapped. It's at the top end of that memory spectrum. I think I have to look at the emulator's source code if I really want to see how the hardware is wired up, but this at least tells me where the main system memory is. So if it's loading relative to that... So what did it actually try and execute? So... I want to just look at the boot messages again. I should probably take a screenshot of it for reference. Hey, Vincent MC. I just realized I heard a ding. Someone did something that made a notification come up. Tokagwa is 89. Thank you for the subscription. All right. Wish I could make the font of this bigger. Okay, so let's take a... Yeah, let's just take a screenshot of this. And I'm going to save that for future reference. All right, so now why don't we take a look and see what that is actually trying to... What code it's trying to execute. Because if we're lucky, it's somewhere in entry, but I suspect that's not actually the case. So, I examine it and I get a crash. Why did it crash the first time? Or did I type it wrong? I may have typed it wrong. All right. So this is what we see here, and that's... Let's see if that has any correspondence to what we see in the Linux kernel. So start is actually at 2000, at 1000. Okay, wait. Chat, that matches up. Okay, look, here's start at 2000, 60FF000C, and then if we look at the emulator, it's got the same value. I really wish I could make this bigger. Yeah, okay, so we did actually make it into the kernel. And then crashed at some point, but we did actually make it into the kernel. Okay, that is actually farther than I realized. I figured it would have gone off into Happy Lala land. So that means we actually need to get into the kernel boot logic and then start. We want to try. What we want to do is actually pretty simple. Is we want to make a call to the parameter to the ROM monitor and have it put debug output out, because that's basically how we're going to be doing this. Because there are serial ports, but this emulator does not emulate them. All right, hold on. There's the Linux folder. Okay. Don't save. Okay. So that basically puts us right where we want to be. So that means we end up here in Arch, Motorola 68000, kernel, and we should be basically here. Hold on. What symbol were we actually? We were on. Yeah, we were here at start. It might be in head. Yep, and this is exactly where we are. Okay, so we have a branch. So it ends up here to this start function, and then where the problem is I don't know where the instruction pointer is. But it did make it into the kernel. So let's try this. Let's tell this to, there is a way to tell it to execute from. I think it's S. I don't know if this one actually does it. No, function code 0. I might have to set the processor register, and I have to set the... Okay, and the rest of this we leave as is. Continue. And then it hangs, which is what I expect. Oh, interesting. That time we actually got something in there. I don't know if that's valid code or not, but that's where the instruction pointer is. What doesn't help is I don't actually know where we are code-wise, or if the kernel is even being loaded to where it wants to be. So let me... So it's going to want to set up the initial stack pointer from this text area. So is the stack pointer set up? Is it program registers? Nope, that's not what I'm looking for. All right, let's try something even simpler. Let's just try setting a register so we can actually just see it in the debugger work. So let's go to our start function. Just to make sure we're actually, like, you know, running code. Now I need to remember my 68,000 mnemonics. So let me get an instruction reference. So yeah, sorry, just catching up with chat. There's another, yeah, there's someone else who's done the port, but I'm doing this as a learning exercise. I'm not actually that interested in running Linux on NeXT hardware. I think it's interesting, but I'm actually just doing this because I want to learn how to do it. All right, let me see here. I just want to look at the move instructions. Okay, so it's move source destination, move multiple. If I want to, I think it's load LEA for loading a load effective address. That's okay, so that's loading from memory. If I want to load an actual value, I really wish it was a nice, I need to find a better document than this. This is nice, but oh, there's a whole wiki book. There's a wiki book that says insert instructions here. Okay, that's less than useful. All right, give me a moment to brush up on this. So this loads. I also have to remember that Gas's syntax is a little bit different than what I'm used to. Okay, so apparently it is just move. I don't know why it took me that long to look that up. All right, let's go to our start instruction. Okay, so JAR start. That is what our first instruction. Yeah, because that's definitely the instruction code we decoded, but is that actually where we ended up? I'm not actually sure, because, you know, I'm looking at this file, and there's, like, multiple macros that could have been the actual start location, which, of course, makes this way more obnoxious to debug. So that's JRA, and the type of branch could have also been changed. I mean, I guess that's where it is. You know, the easiest thing I can do is I can simply add a move here. So let's do move A7, and we'll load it with 77. All right, now we just need to build that. I actually am feeling better than I have in quite a few days. The actually just forcing myself to get up and streaming has really helped. Oh yeah, didn't I have this problem before that it didn't install the compiler as... Yeah, I had to get actually set CC. Like, this isn't a project that I am super thrilled about. This is more me wanting to actually, like, do something. All right, so it didn't like that syntax. Oh, no, it's source destination, right. I'm writing that backwards. So 77, like that. All right, so now let's look at the disassembly. Yep, okay, so there it is. So now we see move AW77. It moves it to the stack pointer, which is actually not where I want it. Let's move it to A5 instead. I just want it in a register that's not likely to be used. Yeah, okay, there it is. Move 77 to A5. So that did exactly what I wanted. Now I need to put this in a place where it can get booted. So the easiest slash only way to do that is from this. Yeah, I actually do feel legitimately a lot better. Not great, but you know, I'm just worried it's kind of the flop before everything gets worse. Oh, I'm gonna have to do 2 copies, aren't I? Okay, you know what? Maybe I can just change the folder next root. Yeah, I could just change the owner on that folder and it would work. Okay. All right, well, now we have a single command to, let's see if that actually did anything. Okay. Break into the debugger. Let's look at the address registers. Huh. So the value wasn't there, but that doesn't mean the code wasn't run. Because those do look like math in the right area, so it could be... Could be A5 was actually used somewhere. Let me just take a brief... Let's take a brief look. I feel like getting it stuck in an infinite loop might be a better option, but then how do I... Let's just do that. Like I said, I want to make sure we're actually running code, and I'm not completely convinced that we are. Because what comes next is I'm going to have to start hooking up the... I'm going to have to figure out... Probably early print K is what comes next. How many viewers are we at today? Like, chat's actually been kind of lively. 56, not bad. Oh, Mugmaster, thank you for these for subscribing. All right. Yeah, I'm actually I'm now that I'm sitting down and doing it, I'm actually surprised at how much better I am feeling. All right, so is that actually doing anything? Wait. The value before was 4D. And a lot less code has been run. Okay, we are actually 4D in... ...4D is 77. Because I loaded it as a decimal value. Because I am big smart. Okay, we are actually in the kernel. So the question is now, how far are we actually getting in the kernel before we take a dive? So we followed this here. And this is basically going to be all nonsense values because none of these values are set. All right, can we get an early print K? Like, let's start figuring out how we set these values. So these values need to go where? The version numbers from stext to start will later be used as the kernel boot table. Jump over our boot info version numbers, blah, 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 blah. All right, so let's take a look at the actual assembly code that this generates. Because I think I'm looking for underscore start. Or maybe int again. See, the problem is that right now I'm not exactly sure where the processor is. We should be here. Then we go through a lot of configuration to test the boot type property. So where did these magic values come from? So we have this get BI record. So that's a boot info record, which believe the boot info stuff is, let's see here, save boot info. If I remember correctly from the other files I've looked at, it goes directly below the kernel in memory. But I'm not 100% sure about that. I think I need to do some searching. Like, where is this function actually defined? So we get this macro, we do a function call, and then we add 4 to the stack. Here we go, function. Find a tag in the boot record structured located right after the end of the kernel. Okay, so we need this machinery to work, so we need the bootloader to put these values in after the kernel. I need to open a new window because we need to add some code to the bootloader. No, I didn't want to go to my NAS. Sorry for not describing. I'm trying to port NetBS Linux to NeXT hardware. There is apparently a port that's already been done. I didn't find it when I did my cursory search, but people have told me it exists. But I'm just doing this as a learning exercise. I've always wanted to do a kernel port, and I always have had a fascination with NeXT hardware, so I kind of want... I just... My end goal, like, my vintage computing, like, when I have one vintage computing, is to do a full operating system port. And I have some interest doing it on NeXT, but just getting experience playing in kernel space and breaking off it's been probably over a decade since the last time I did anything like this. But this is also why I excuse me, pulled the bootloader out so I could modify it separately, because I knew I was going to have to do this. Okay. So from what we saw earlier, it pops into main, and then it goes to the, okay, I see how it does this. It pops to main, and then it goes to the kernel start address that's in D0. So that's how we pop out of here. So that's how the bootloader basically makes itself disappear. Interesting way to do it, but not a big deal. So we need to write that. We need to write a boot structure under that. So we need to find the format of said boot structure. So kernel load address. All right, so boot arguments. So what actually copies in the kernel? So this is right before we do the entry, is right here. This does a whole bunch of parsing. And this looks like that does a direct read into kernel memory. Let me see here. Hold on. I feel like I'm not seeing all the code here. Okay, so we have our load file. And then this does a whole bunch of dev parse stuff, which is the stuff you see as it basically downloads. Yeah, okay, so the kernel is loaded here by load file. So let's look at the top level load file, just so I understand what we are working with here. So load file marks. Okay, so so it does read that in, and then it reads in the values, and then it runs on a loop to basically go through all of them. I'm not completely sure how the marks start end is calculated, but I don't actually need to know, so I don't care. So let's go back to boot C, which is not in this folder. It's in the top level. Okay, so entry marks end, kernel load address. What I need is the length of the kernel. And when we look at the kernel boot messages. Okay, hold on. The oh, dogs are losing their mind over. That's the bootloader crashing. Yeah, I'm pretty sure that first number is the length of the kernel. Now, what is the kernel's n variable set to? Because that should have a symbol value in the kernel. Okay, it does have it set. It's set to D8. No, that's where it is in memory. I need to see the value. Or is that... That says BSS. That may be a runtime thing. Hold on. So you look at underscore end to figure out where you come from. And nothing useful comes from that. So we also have these BR tags size. So this basically forms each one of basically what the boot record is. So basically, we're going to want to put a breakpoint here, and the way we're going to have to do breakpoints is... Well, actually, I should see if the processor has a built-in breakpoint thing, but I think I'm going to just have to put an infinite loop and then jump past it. We're more specifically basically getting a grand total of like 10 opcodes into the kernel. We are not getting very far. Oh, you are making my life kind of annoying right now. Okay. Where is BI record defined? Because that's the data structure I need to make. Okay, so it's in UAPI. Boot info. Okay, so there's a tag, a record size, and data. So I don't know what eSIM is. That might be symbol size. Let me see if I can... Because that's what everything adds up to, so that might be the length of the kernel. Because basically I now need to make two separate code bases agree on something. So eSIM is marks n minus kernel load address. So that might be where these values need to be. So how big is our kernel in actual bytes? That's a different value. Oh no, but it may still be correct. Now that, hold on. When the kernel unpacks into memory, the BSS segments that's uninitialized memory will be allocated. So yeah, hold on. That might actually be correct. So eSIM might actually be the bottom of bootloader memory. I need a way to know if it actually is. So I think the easiest way to do that is we are now... This is the wrong window. This is going to be very slow coding because this is also me learning how to like effing do this. I kind of want to see if we are getting to this get boot info record. Because if we are getting into it, then we are getting a lot farther. All right, let's just stick an infinite loop here. And let me make sure I didn't leave one near the top of the kernel. All right, I didn't. So let's see where we end up. Okay, and then we hang. So D800. That value came up before. Because that actually would be what I would expect if we've stopped where I think we've stopped. I didn't mean to break into the bootloader. Because I'm pretty sure I saw D800 for end when I was looking at before. Yeah, that accidentally blew away all my registers. So let me get back into there. Let me look at that again. I am assuming that I am actually crashed where I'm assuming I'm crashed, which is not a guarantee. Okay, all right, so now we're there. Capture, break, address. So we get 40D8000. So the reason I'm not completely discounting that as a valid of the valid thing is if it may have allocated a full page. So that would be 40D8000. If the kernel loads in at 402, is it? No, I screwed that up. Hold on. The kernel load. Let me look at my handy little screenshot. Kernel loads at. Because I'm trying to figure out if that's that value looks correct to me, but I want to make sure I understand how we're getting it. And then we subtract 40020. We get a little bit over 800 kilobytes, which seems too, no, that's too small. I mean, this is a tiny config, but how tiny is it? Yeah, I don't think that's the end value. I think that's something else. Let me see what we're dealing with here. We may not even be getting this far, which is a little concerning. So entry to start. And I stuck an infinite loop. Yeah, I stuck the infinite loop here. Let me just put another value in to another register just to basically give myself a canary to make sure I am even getting to this part of the code. Because I don't understand exactly where it's looking for, if it's looking for the end of allocated memory or just where the kernel binary stopped. I was never like, I always found that I have to go very slowly with bare metal stuff or I will get myself hopelessly lost and confused. Okay. Oh, and that's what happens when I hit the break key and I'm not locked in the emulator. All right, so let's look at the address buses. That looks like our special canary value. Yeah, that looks like our canary value in, yeah, so 1E61 is 777. Okay. I should load it in hex, but yeah, okay, so we do get here. So it's trying to load from found right after the end of the kernel. I think this is program counter. I don't recognize the syntax exactly. Time for me to look at 68,000 addressing modes. Oh boy. I am starting to remember. I'm starting to understand why so many people thought I was nuts for looking at Motorola 68,000. So yeah, it's definitely at least getting into the start reading the boot records code. I just don't know why it's loading from this location. Probably because there's a default value somewhere that I haven't found yet. Let me take a full ob jump of the kernel, just so I have it handy. Okay, so here's int begin. So this is how it actually comes out to object code in the system. So it does a lot. Okay, so int begin, memory mapped address, and yeah, okay, so it's basically trying to inline basically all the. It looks like it's doing a bunch of inlining, I think. Hold on. Yeah, so here's the code. Here's the code that we are at, but this isn't making a very good disassembly, unfortunately. So load program counter D8. Okay, so that's where the D8000 binary plus int end comes from. I hate macro hell. Alright, let's just do a little grep in the kernel and see if I can find where that magic number seems to come from. Of course, that would be too easy. Like, I don't know if that comes from the bootloader, how it's getting that value. It is currently a mystery. All right, so we get this function start. So it loads. Gas's syntax is unfortunately different than basically what any documentation uses, which makes this much more annoying. Um, yeah, I should look at chat just to see what folks are saying. Doesn't look like anyone said anything in a bit. Huh. What's at the bottom of this file? So the binary finishes at D5EBC, and if it's using 4 or 16K pages, hold on. it's using 16K pages, then that would be a page boundary. So the end value would be calculated off the highest page that it would be using, ... question mark. Expanding the macros might not be a bad idea. The problem is that this is doing deep voodoo that I'm not completely cognizant of how it works. And I'm not sure... Yeah, okay, hold on. Why don't we look in the kernel linker script? Oh, Lord. I've... It's been a long time since I looked at one of these. Because this basically tells us everything of how thy kernel goes together. Because it basically lays out where the kernel sits in memory. So yeah, there's the entry point. Sections at OX 1000. And then we have int begin, int data. And then we have the fix up stuff. And then everything at the end. And we have kernel end down here as a symbol thing. So memory start, memory end. But this does look like a different symbol. This is... I always hate when code does this. Yeah. Oh, here it is in the kernel, in the LDS script. Okay, so it is, that's where it comes from. Yeah, so this would be right at the end, which... I guess it wants them on the next page? I don't know if that makes sense to me, but... See, I don't think this is doing any sort of memory allocation. Problem is, I don't know how to make this right in the general course. Boot.c. Let's look at one of the classic macOS bootloaders, because this generates the structure we need, and, well, it's also Motorola. I believe this is the right repo. Yeah, because I remember looking at this. This was int kernel, and then it has the scripts to like actually enter the kernel, sets the destination address, jump into the kernel, never come here, yada yada yada. And then you have the boot environment file. Which I believe would be, yeah, this looks like this is all the right environment stuff. So set environment, but how's the environment actually get calculated? Like, or maybe tier boot info is actually the file I should be looking for. Extract banks, boot info, int. Okay, command line, boot info. Because like I said, I did look at this beforehand. Let me see here. Load. We have load kernel, stream open, blah, 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 blah. Stream read. Yeah, so this reads the entire kernel open. Check full in bank. I think I gotta download this code just so I can look at it more easily. I didn't expect this to be easy, and it definitely hasn't been. Yeah, I mean, this is definitely deep voodoo. Alright, so we got all the boot info stuff here. So this looks like it puts it directly past the RAM disk in memory, which actually makes perfect sense to me. Assuming, yeah, let's see here, extract banks. But this does look like a global variable. I always find this part. I always find this type of thing to be really difficult to visualize in multiple ways. Okay, so if we look at the boot messages that come out of the bootloader, it calculates their entry and exit, as well as I think the full code size is one that is all added up. I forget what those values. Those values do have meaning. Yeah, so entry and then eSIM. See, I would think eSIM would be symbol table or symbols, but that may be true on NetBSD, but on Linux, I don't think that's actually pointing to anything valuable. A mark has to be a length of data. So equal process arbs. Because all this prints out. Okay. I mean, strictly speaking, I can put this data somewhere else and basically have it found, but I kind of want to understand what's going on here first and how these values are actually calculated. If it's rounding up to the full next page, that would make sense. So each record has a tag, a size, and data. So if we go look back at, and that header is, let's see here, we had it here. Yeah, so we had tag size and data. So let's take this structure and let's put this in our bootloader. Let's actually make some progress. Like, even if this isn't correct, I can sort it out later. All right. So this is where we return here. So what we want to do is we want to find this structure like that. I have to fix the sizes. Then we have all the various tag types here. So last record, machine type, independent tags from 00, machine dependent from 0800, RNG seed. Okay, so it is looking for this magic. A starter kernel. Bootstrap checks for matching version of the interface before booting a kernel to avoid confusion. Blah 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 blah. So where's this magic check? Let's get rid of this. Okay, so this value must be for the bootloader. Yeah, so it has stex. This has got to be a header for the bootloader to look at the interface and see if the kernel's compatible. Okay, so we don't actually care about that because our bootloader is very iffy. I've been in very poor health for an extended period. I'm only now just kind of pulling myself back together, and I'm sort of doing this as a force of will more than anything else. I'm not convinced. I'm not ready to get this up. I'm just ready to, let's see here. So we set the initial stack pointer here. And then it tries to get the first record of machine type. So what we want to do is we want to make sure that it gets that first record of something else. So size and data pointer go into A0. Okay. All right, I'm just looking at how this jump sequence works. So it tests if it's a tag. I'm kind of struggling to think of what to do right now. Like, this is the problem I have on large projects is I feel like paralyzed, and what I've learned is like just do something and maybe I'll move towards it. So I have the by record strut. And we're going to need all the tags and stuff from the other thing. So I'm just going to make a mark. And then let's copy. I don't know exactly how the kernel is calculating where it needs to load, but we can kind of just take it on faith and just set a pointer to that address, I think. So define kernel load address, NeXT RAM base. Let me just take a look at some of this. So I'm assuming RAM base, that file isn't here, that's in the NetBSD tree. I'm guessing that's going to be OX 4 million, if I had to take a guess. And I don't need help with network share issues, Windows. Especially when it's just my own typing that sucks. Alright, so I want to look in sys. Yeah, I want to take a look at the top level NetBSD kernel. I don't want to open a file. I want to open the entire damn tree. Actually, I want to look at the built. This may not be actually the right directory I want to look in. Which file was it looking for? Machine CPU. Yeah, I think I actually want to look up one a folder higher. There is no machine folder there. Here it is. Nope, that's the wrong one. That's news, not next. But at least now I am much closer to the right direction. Alright, so it's blah, 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 blah. Yeah, so, okay, so it has the hard-coded in OX4000. So that's where the kernel load address goes. So that's the top of memory. Okay, so now I understand the bootloader behavior a little bit better. That makes perfect sense. The bootloader then loads at the bottom of memory, and then the kernel is loaded at top. And we're all happy. Okay. So yeah, we get the kernel load address. All right, so let's just try putting some stuff in memory here to start off with. So we have this uint, and then we want to go D8 OX D8 0 0 0 0, and then we're going to put some patterns here because I want to look at this with the memory monitor. So if we look at this now and we look at examine and we go E0 D8 0 0 0, there's nothing there, which is what I'd expect. I think I've got one too many zeros here. Yeah. So this should now put something in that memory where the kernel code is looking for it. So let's rebuild our bootloader. Yeah, I probably got to put that in there like that. Okay. That all works. So now we can copy that. And now we can take a look after this boots and see if we see anything in that memory space. Okay, and we crash as expected. Uh, those values look wrong, but that was something that wasn't there before, I think. Okay. But those aren't the values I'm expecting. Let me check something. No, those aren't the values I'm expecting. Okay, so print entry. D8000 and 004. And we did check the kernel load address, so that is what it's supposed to be. I mean, that doesn't look right to me. Which tells me I am almost certainly doing something wrong. Let's see, a kernel load address. All right, let's just do that. I think I was having it make a pointer of a pointer instead of doing what I actually wanted to do. Yeah, that okay, that looks correct. So, all right, let's see if that does anything. See if that actually puts the start of a boot record where we need it. All right. Hey, chat, there's our values. So that should be what the kernel sees at that memory location. Okay. So that means we can now put values in where it's supposed to find, stuff, which is kind of a good thing. All right. So So now we want to put a strut BR record in that location. All right, so what is the tag ID? Size of record in bytes, and then data. And let me look at the boot code in the kernel to make sure I fully understand what this is doing. So basically, this is the wrong file. Yeah, so this reads in the tag, it looks in for the size, it gets the data, and then returns it, and then it... So yeah, it's going to want the mock type, FFU type, CPU type. We don't care about all this code for the Macintosh. And then... this determines what processor we're on, and then starts setting up the cache stuff. The numbers it prints out is the size of the text section, BSS section, and some other data about the ELF binary, including its total size. So what is mock type? Machine type. Okay, so that would be machine type, and then we'll define a new one, mock next. I'm gonna grab a drink. All right. So, given that, let's see if we can set a mock type of 16 and then get that read in by the kernel. So we need to find a structure. Okay, hold on. I gotta remember how I'm gonna do my C programming works. So that sets the boot record. Tag is BI. Mock type. Size of the record in bytes. So if it's a 32-bit, it's going to be 4. And then it's going to be 15 for next. Oh, yeah, you know, that would be the right syntax. God, I am legitimately this is like completely atrophied out of my brain on how this stuff works. If I wanted to find do I need a void pointer? No, it's not a void pointer. I need to remember how you define it. Is that the right syntax? I have that horrible feeling the answer is no, but let's just see if the compiler takes it. BI record undeclared. Oh, I have to define this as a type, don't I? Yeah, hold on. It has to be a type def. Good lord, okay, that actually built. What did it actually make, though? All right, you know what? We're just going to send it, and we're going to see what's in memory. And hope that it actually comes out correct. Oh wow, thank you. Emini Ellie 5 ARS. Is that Argentinian peso? No. Sign cat. Okay. I I appreciate the super chat. I'll put it like, if I'm slightly confused by the contents. All right, let's see what that put into memory. Chat, that looks correct to me. It put an 01, 04, and an 05, and an F, which would be type record 1, size of 4. Well, actually, it's in bytes. So it would be actually a size record of 1, but that's just because I typed the wrong thing in. Wow, chat, I wrote code on the first try and it effing worked? That feels wrong. Okay, so if that is actually the case, let's go to the kernel. That's the wrong file. Here we go, right file. So, okay, so that should set... That means that this... Yes, yes, I know it's magic numbers. This is why device tree exists, and I'm not... I'm assuming that the end address, it has to be, the way I look at it has to be the beginning of the next 4K page after the kernel loads. It's the only way that value makes sense. I just haven't got the slightest on how the link, how it's getting up to where it's ending up. But I'm okay not understanding the deep magic. I'll regret that at some point, but... So is this a static address in the kernel? Because it looks like it's... Does the PC on this on Motorola 68K not work the way I think it is? Because that code, if it's referencing off the program counter, I would assume it'd be the relative position it currently... Yeah, a current instruction being read or written. And then it loads effective address. I don't understand this syntax. Essentially, compute address of table with respect to the program counter. And then deposits it in A1. And then it moves the value from A0 to A1. Just want to see how much more code it's going to churn through. Because the cache type should be something we do support. And then, yeah, it does a ton of platform-specific code. And then tries to initialize a console of some sort. And that brings us basically right up to the start of MMU initialization. essentially we want to get to this put C, because that put C means that we're going to have to set up a way to have the kernel talk to the ROM monitor so it can print out. Yeah, I mean, it makes sense. As I said, this is really an exercise in learning for me more than anything else. So the biggest question to figure out then is, where does this variable exist in memory? And does it get set correctly? Not this variable, but this one. Because I have to work with the debugger I have, not the debugger I want to have. Wrong folder. Okay, so we do get the memory address from that. So it ends up in C5909, which may change when we tweak the code slightly. But if we did it correctly, we should be able to do an examine in the kernel and see it in there. So let's do that and see if all this hard work has actually done anything. Alright, so let's put an infinite loop here. Because that's all as far as I want this to go. And let me make sure I remove the other one. Yeah, I did. Okay, cool. So now let's rebuild the kernel. Okay. So now we just need to look at that memory address. And see if it's in there. Examine 02508 90. Yeah, it's there. Check that out, chat. 00F. We can look at the assembly listing here, and we can see that it's loaded to C5090, and we know the value is F because we set it in the bootloader, and that basically worked. I'm astounded. All right, that means we need to set the rest of the boot parameters. So we need to set the FPU type. which I don't actually know which FPU we have. I don't know if it's a 1 or a 2. Although actually if it's 40, which is what we are targeting, it's going to be that internal FPU. So yeah, we can set the MMU, we can set the FPU type, CPU type. That should get us all the way down to MMU initialization. Oh. Yeah, we actually got some progress. We have the first boot variable initialized and loaded, which shockingly was actual effort. I mean, it wasn't as bad as some of the things I've done on this channel, but not the easiest thing in the world. So FPU type is going to be that. I always hate when code gets... Yeah, okay, so it's... Why did they make that a bit field? That's weird. Okay. So let's do the initialization for all the other ones. So we need to change our boot record. Okay, so the next one we need to set. Yeah, we'll do this. We'll just go right down the list. BI CPU type. This is really terrible coding. All right. FPU type. MMU type. I think those are the ones it wants right now. FPU, MMU, CPU, and yeah. Okay, so those are the ones it wants right now. The MMU is going to be kind of a pain because I have to figure out how that all works. And I also need to figure out the values for all this. All right, so CPU type should be the easiest. CPU type is going to be... You know what? I'm just going to flipping copy and paste these so I don't have to worry about it. So I can't possibly make a mistake. All right, so we are CPU. And then we are FPU. And then what is MMU type? Assuming there's MMU 68040, so I'm assuming that's what we want. I think, yeah, I think that's all correct. We'll look at it on the booted system to make sure I actually like put valid things in those places, and like we have like stuff in memory. NetBSD stand. All right, let's take a look. That doesn't look right. Yeah, that doesn't look right at all. Did I? Okay, I goofed somewhere. Let's take a look. Uh, I have that feeling because that's declared as an array. It's the size of isn't calculating correctly. Because I have tag 1, tag 2, the size, but the next value doesn't show up, which was working here, so this did get written to the right location. Yeah, it's only, yeah, I just need to think about how to. This is definitely not the right way to do this. I just am trying to think of a better way to do it. Yeah, it has one element in it. And I am confused. Okay, hold on. So we set the boot record, we increment it. Let's look at the generated assembly just so I can wrap my head about what this is doing. I am obviously making a stupid mistake. I'm just not sure what that mistake is yet. Because the bootloader blew up when I tried, and I got so sick with futzing with it, I decided just do it this way. So this is my own code. This is good enough for what I'm doing. It's not like it changes. Like, if when I get deeper into the MMU machinery, yeah, I can kind of see the want and need and desire. Yeah, the size of is only calculating uh it's calculating the size of the pointer. It's calculating the size of the pointer. That's what's doing it. Is that what's doing it? That doesn't seem right, because when I looked at when I looked at it, yeah, so it loads 8F. So printf move load. No, pointer would be 48. Yeah, so it's only moving. I really think my C is just really this rusty. Does that work correctly? I don't think that changed the code generation, because it's doing +8. No, it's because, okay. That's the problem. I really feel like I'm starting to I'm losing my mind here. Yeah, it definitely is write only code. My biggest problem is that I am my C is so rusty. I can't believe how much it's atrophied. Um, all right, you know what? Just because I am actually questioning my sanity here. Hold on. Size of BI record. I am actually questioning my sanity at this point. Okay, so it is saying it's the size of 4, so it's saying it's the size of the pointer. Um, I might just have to add 12 manually, which definitely doesn't feel right, but like I said, I'm more interested in this point just getting through basic problems and getting it actually done correctly. Yeah, it puts size 4, which is not correct. It needs to be size 12. Uh, Actually, no. I take that back. Hold on. It's a pointer. It's a pointer. Okay, no, the way you think about it is it's a 16-bit value, it's a 16-bit value, and then it's a 32-bit address to where the array lives. Is how it would be laid down in memory, and then the data would be at the base address of that array. I'm trying to think if that actually sounds correct in my head, because it does sound like it does feel like it needs to be a data structure, and then a pointer to that data. But it did load correctly before. Yeah, you can send me a link. Hold on, let me see. The easiest way, I have to make you a chat moderator so you to be able to post. Yeah, you know what? I'll just make you a moderator in chat so then you can post chat links in chat. It looked like when we looked at the code in the kernel for getting the CPU value stuff. Yeah, wrong file. In the kernel itself, it goes for machine record type. It... Yeah, when we go to the BI record... It looks for the tag. It looks for the size. Yeah, so I would think it would be a pointer to a pointer. All right, let's take a look at this. Just... Yeah, I mean, definitely would be cleaner. Like, it'd probably be easier just to build it in memory and then mem copy it to where it needs to go. Yeah, because I'm looking at your strut. Let's see here. Log data 0. Yeah, because what you do is... Let's see here, because I have this defined... I think I just have it defined as an empty array in mine, initialized array. Instead of having it declared to 0. Actually, note that I just realized that makes perfect sense because it would be... It's a 32-bit register. It's 2 uint16s, so that would be 2 plus 2 plus 4. If it was... The array was completely uninitialized with no space allocated. Okay, now when we do a rebuild, it should actually... I'm pretty sure the size of it's going to be 8. I don't think it's going to be right yet, but I think it'll be closer to the right direction. No, BI is still 4. So what am I doing wrong? I'm like kind of losing my brain on this one. How do I not know how? Yeah, so the entries are variable length. So okay, so it's yeah, okay, that is what I thought it. So it's the header, it's the size, and then it's the data laid out in memory consecutively by the value of the size. Okay, that makes perfect sense. I am just very confused on why I don't get 12, the answer I expect. Size of strut and see. Let me just Google this. All right, I'm just going to increment it by 12 because this code needs to be made a lot cleaner. Or no, it would be by 8, not by 12. Wait. Is this going to... I'm just trying to think if... I mean, those are 16-bit sizes. It should do the right thing. So, because these two should share a value, this should share a value, so that should be +8, +16, and then +24. All right, let's just build it and see what actually comes out the other end, because at this point, I'm having visualization problems with this. All right. Okay, mouse is locked. So now we want to examine 80D888. Yeah, that looks correct. So we load 1. I mean, those values look correct. So 00301, 001, 004. Let me see if I can remember that memory address for the kernel. Was it? It was 8C. Nope, I was way off where that was. It is C5909. Yep, and that's loaded there in memory. So if we look a little higher up in system memory, okay, so I must have, oh yeah, this kernel I think has the breaking loop bytes. But that should be all the core memory values, like the very early ones, set and initialized. Yeah, because we have this looping code. So if all these are set correctly, it should do a whole bunch of various testing code and then raise the do we run this branch? It'll run through a lot of this branches to basically determine what it can and can't do. And then it'll try and initialize the serial port, which is probably going to be our first bit of platform-specific code. Because, yeah, here it tries to start dumping stuff to the early print K kernel, or the early print K monitor. So in theory, we should basically be getting all the way down to here. So let's find out if we actually are. So let's do a move. And we'll stick that in A5, and then we'll do an infinite loop here. And we'll see if we actually get all the way to the point where it's starting to put out debug info. I don't know if it's going to get that far. All right, let's take a look and see what we have to work with. It didn't die with a new exception, so that's actually kind of a good sign. So we break out, and A5 is what we set it to be, which means we actually ran all the way through head S to the start of trying to actually initialize the... It's not going to be able to map this because I haven't set these chunks up yet. But we've gone all the way to the point that it's trying to use the debug console. Oh, 16-bit alignment. Size of the data, so size of the record plus entry size. Oh, okay, yeah, you know what? That's a way smarter way to do that. Like, that is a way smarter way to do that. But I'm actually really pleased with that. That means we're now at the point where we kind of want to talk to the ROM monitor. So if the size is in bytes... Okay, hold on. Size of the record in bytes. Okay. Okay, so the size would be 4 because we're saving... Oh, I see. So I could do size of the record 2 and then size of the record 4. Okay, yeah, that makes complete sense. Um, so it'd be size of BI record plus entry size, and then I'd have to multiply. Actually, I just want to add it to itself, to be perfectly honest. Is that going to do the right thing? Probably because I eliminated. No, I have the set. I suspect that did not work the way I wanted it to work. Uh, I have that horrible feeling I took working code and I broke it. F1, F1. Yeah, I'm just going to run it and just see if it actually, what it actually does, because I've only been doing this for 3 hours, but I feel like my mental energy is starting to drain. Oh, you have to cast it. Okay. So entry equal. Actually, let me go back to where it was. Okay, hold on. So here's my base record. So entry. I was only using NetBSD's bootloader to start the actual project. Okay, so entry. I'm trying this. I really suck at computer programming. hold on. I'm just going to write it out in a longer form just so I'm not struggling with this. So plus the size of boot record. So every entry has its own size next to current, struct size, and the data size. I'm just imagining someone face palming on the screen and how badly I am. Wow, I am definitely. Yeah, so you went 8T. All right, so we cast the boot record to that. Then we want the size of the record plus the size of the entry. So wouldn't it... I'm not sure I have this correct. So I have it for the size of the record, which would be 4 because it's 2 UNT16s, plus the size of the data field, which would be 32-bit because it's loaded as an address. That's how it's defined in the code. And then I don't want to actually take that as the size here. Because that's the base size. Why doesn't that work? Or does that work and I'm just... Because it should increment in place. Nope, invalid assignment. Boot record. All right, Paige, have a good night. Cast to the pointer of a different integer size. Okay, hold on. Boot record's a volatile pointer, so yeah, I need to cast it. Doesn't want to be a 16 though. Initialization makes pointer from it. Initialization without cast. I think I'm going to step away from keyboard for a moment just because this is... Let me just do that. I'll take the warning and just see what it actually does. Always really terrible with this. Boot record plus or equals boot record. Entry plus entry size is correct. Okay, okay. So I was actually correct the first time. Let me see if that does what I think it's going to do. God, sorry, my brain has like completely just decided it's going to quit right now. Examine 40D8000. That didn't quite work the way it was supposed to. Four, 8. Because now it's loading. Let me just look at this in bytes. Hold on. Why is that crashing? Is it EB? Nope, that works. Okay. Am I just losing my mind? I mean, possibly. I'm just gonna restart it because at this point I'm... Yeah, I'm not sure the kernel... I don't know the kernel's alignment, how it wants it. We'll figure it out bit by bit as we get to it. I am actually really happy with this progress because at least it's partially correct, which is a lot more than not even being present. Yeah, that's odd. I can examine it like that, but when I want to examine it as bytes, it has a fit. I don't even know. All right, I think the sizing's off though. I just haven't quite figured out exactly what the sizing needs to be. If it's in bytes, it needs to be a 1. Because that's 8 bits. I'm not certain if it wants things to be aligned or not. So it would be a 32 word, and it would be two 32-bit words, which would end up with an odd sizing. Yeah, see, that's the part that I'm... Size of boot record plus size... I mean, maybe it's -1 is actually what I need. Because my honest brain thing here would be, it would be +8 past each address. Because if it was +8... The entry size is the total size, so... The entry size is the total size, so size of... is not the data size. Oh, okay, so it's the whole size of the boot record. So... Okay, hold on. So if the boot record is 4 bytes, so 2 for the tag, 2 for the size, 16-bit, and then 4 bytes for the data. So that means the size would be 8, wouldn't it? 4 plus 2 plus 2. And then if I increment it each time by the size... it should line up correctly. No? I'm going to just set the size... I mean, that... Yeah, then we only increment it by size directly. That actually makes sense. assuming that the size is the full size of the record and not just the size of the data. But that problem will become evident pretty quickly. And at some point, I could always take apart like a Macintosh bootloader and like dump its memory to basically have it. Yeah, so that should generate the correct a proper pack. Why am I getting exceptions there? Am I typing it wrong? Why can't I examine that memory? Yeah, I'm just going to reboot it just in case the ROM monitor is in a bad state. But that's odd that I couldn't examine that memory. Why am I just getting an exception when I try to read that memory? Four zero D8 0000, and it crashes. What's exception 08? Privilege violation. What? We shouldn't be... What? Okay, I see what... It's... Okay, hold on. I'm going to back this up because I am deeply confused on what's going on right now. I don't understand how I got here, how it broke. Okay, so you continue the BI record. So entry equal entry plus size. Not sure if the kernel expects the record entries to be aligned to a 16 boundary anyway. The entry size is the total size, so size of BI data structure is not. Then you only increment it by size correctly, but then the increment is done bytes, so entry plus size, because you continue. The only part left to understand is if we want the 16 aligned. Yeah, I know the font in the emulator is barely visible. There's not a lot I can do about it. That's the font it uses, and I can't make it bigger. All right. So this is how I left it on the most recent go-around. And somehow by doing this, I have, like, broken it entirely. Let me see if I can do something about this. Let me see if I can make the display any bigger. No, not really. I'm not seeing anything. Most I can do is if I hit maximize, it kind of scales it a little bit, but not by a lot. Oh, okay. All right. Hold on. So size of BI record plus boot record size -1. Okay, so now we get into the bootloader. Now, so the question is, can I now do a memory examine without the whole thing, like, freaking out? No! Wait, now it's okay? I don't even. I really don't even. Okay, so this does put padding. Okay, so it wrote it at 1 FI 00. So it put an extra padding that I don't think we want. Oh, it's interesting how that works. Oh, right. Cast it to UNT8. So your size of boot record. size of entry. So this is 4 plus 4 would be 8 minus 1. Well, these aren't because I didn't set these correctly. And if I look at these in memory, see, I think they have to be packed right next to each other in memory. So size of, so this is 4. 4 plus 4 minus 1, so that puts us at 7. Because technically that one is wrong, actually, but... Cast it to uint 8, so as I said, entry equal uint 8 entry plus size. Oh. No, see, I'm really trying to visualize it in my head, and my brain is just not having it. Uint 8t, just for the sake of me thinking about, okay. So it'd be the size of the record itself plus the data minus 1. We're doing the size in bytes, so a byte is U32, or no, uint 8. God, I'm actually starting to lose my mind over this. Give me a moment to just collect myself. Okay, so if this is the size in bytes, and it's always defined as a uint32, we'll set it like that, and then we'll just kind of see what happens. I just set that so it's an easy searchable pattern. It's not, it's just a place, it's just a magic value. Oh, okay. All right. I'm seeing. And then that's pointer size. I always hate how completely terrible I am at this. Expected initialization. Expected initialization parameter before. Chat, I'm honestly about to throw in the towel. This is actually driving me crazy. Like, I feel like. No, it caster from integer of a different size. Nope, that still gives an error. I copied it straight from the YouTube chat, and it still gives an error. Oh, it's BI record. Or, volatile BI record, no boot record. All right, chat, I'm just going to assume that's going to work because that feels like complete magic. That's what I get for doing first, like, bare metal stuff in I don't know how many years. Helps if I type in the right memory address. And then I get exception 2 again. Four, 4. Yeah, that doesn't look right at all. Did I mess up my code? 40D8000. Wait a moment, chat. Hold on. Yeah, no, that's the right number of zeros at the end. This is the memory address of where the kernel is looking at, which is the next page from its load address. And we've tested that. It was loading before. Now it doesn't look like it's loading anything. It doesn't look right at all. Because it's probably not... I gotta look and see what the boot generator code looks like. So it loads that value. Okay, so this is the first load where I basically put it in by hand. And that ends up in the right place. And then... So yeah, it loads that value into a register, and then loads that register to address line 8. So then it moves down 1. Or moves value 1. Okay, so then moves AL minus 8. Oh, okay, I see how it's doing, because it's loading at two 16-bit values. So it's loading 1 in, and then 4 as the 16-bit. Then it loads here for 8 total. Then it moves let's see here. Trying to... Yeah, value records goes at the end. No, it's... I got the address from looking at the debugger where the kernel's loading, which looks like it comes from a symbol called end, and end is defined in the kernel link script as the very end of the file. But it looks like it allocated onto a fresh page, which I'm not sure is correct, but it's memory that the kernel says that it should be. And when we put a value there, the kernel did find it and it did load it. What I am really confused about is we still have printf available here, so why don't we just use it? See if we have... I don't know if I can print out by hex, but we're going to find out. I thought I did increment it each time. That's why I'm checking, because I'm really feel like I'm... Yeah, so incremented it by 4. Which isn't correct. Two. Well, I'm like, if it's the size of this total record, then this would need to be incremented by 8, like that. Because 2 plus 2 would be 4, plus 4 would be 8. Because it's 16, 16, 32, so it's 64, so it would be 8. If that is actually how this works. But then that can't be the size in... Yeah, I guess it would be the size in bytes. Hold on. It's... Size of the record in bytes. Assuming it can... Yeah, assuming it's counting itself, then that is correct. And we'll find a better way. We'll figure out a better way of doing this. I just want something that actually, like, works. All right, I think I'm going to take a break from this, and we're going to look at how we have to get the ROM monitor kind of plugged into the kernel. I do have a hello world binary, which I can work from. Okay, cool. And that doesn't even feel like it's writing into the right place anymore. I did build it. I did SCP it. I am very close to just throwing in the towel for tonight. So, excluding that, I'm going to just go and look at the kernel code for a little bit, just to get an idea of where we have to go now. We need basically early console, and early console, this means I want to be able to print out to the boot monitor. It's not console, or if defined Mac. Trying to remember, is it serial int? Maybe serial int. Yeah, serial int not Mac, and then this basically sets up everything for the early kernel boot K. And then you have a whole lot of spaghetti code here. Yeah, that is a lot of spaghetti code. Yeah, okay. Yeah. I'm starting to remember the spaghetti here. So basically what we need to do is we need to put either console put C or serial put C and make it go somewhere like useful. Let's see here. Yeah, I think hijacking the serial put C is going to be easier. I might have to pass in the ROM monitor pointer to the kernel through boot arg, so I do kind of need that to work. But at least it's like in the right direction. A sign is missing. Okay. All right, let's just see if that works and put me out of my misery, please. Well, that didn't work. Look where it put the second record. I definitely screwed up something. All right, I'm just going to copy and paste the correct line because I am obviously mentally spent and chat is carrying me. Hold on, how's that different than the one I just did? Oh, I need to print up the second boot record. Yeah, that would do it. Chat, you're definitely a great backup brain for when mine is just not having it. See, that incremented it by 4. All right, I'm just going to look at the memory, and we're going to just see if that's correct. No, that's still not quite right, although it's definitely better than it was. Because now it just piled up one on top of each other. Okay, so we increment it by boot record plus the size of the boot record. So it should be the size of the data, so that means we need to increment. All right, so because I thought it was the size of the data. Because it's defined as a U32, which means we need to increment it by. We have to increment it by 8, not 4, because it would be the size of the boot record itself, and then size of boot record. Or. Yeah, it would be size of boot record. The strut definition may not be correct because the size itself, the kernel comments are inconsistent on what this is supposed to be. But we're just going to go with it, and when the code explodes, we'll know what it's supposed to be. Because right now we do need those values to come in, because I'm actually going to have to add one. I have to pass the... When the bootloader takes control from perimeter RAM, it gets the address of the ROM modder. We need the ROM modder address to be into the kernel, and I don't want to hard code it if I can avoid it. I dislike the hard coding I already have, and I want to figure out a less stupid way of doing this. But All right, let's see what that gets me. Okay, chat, that is actually correct. Or at least that's what I think is correct, because we have two 16-bit values, the 32-bit one, and then the next value starts immediately past that, and those are the values I would expect to see in that memory address. So that sucked. That legitimately sucked. I'm actually going to write some notes down. Yeah, let me grab a notepad. I'm going to write, let's get a new file here. Pain and Suffering Notes, Linux NeXT 64, day 0 through day 1. All right, so day 1, all right, because I think this is the 4th stream, so so day 1, it was isolate net. All right. I'm just keeping some notes for myself because if I make a video out of this, I'm going to have to keep it start. We're not even that far. We haven't even initialized the MMU. We have literally given the kernel the absolute bare minimum it needs to get to the memory initialization code, which is here. Here we go, infinite loop. Yeah, we are right here. We basically, it tries to run the serial int code, which we don't have. It tries to do a lot of console display setup and figuring out what CPU it is. It's not crashing, which is actually kind of a good sign, which implies it's getting through the CPU detection code. What I want to do now is I want to get the early print K working, because as the kernel runs through head S, it will put out letters to say how far it's gone through its initialization. So we've currently gone to letter B. I believe, I forgot what A is. Oh, A is right here. A is it got through all the early initializations. Now the next thing it does is it tries to start loading the page table and calculating the physical addresses. I don't have any reason to believe this won't work, but that's step B. And then it goes into step C, which is it tries to work out the chunks required to set up the MMU. And so you can see here we have the memory map. The memory map is probably going to be... I have to look at how NeXT does it. NetBSD does it. I'm assuming the memory basically gets allocated in a single chunk, but we can hard code it in the config pretty easily for now. If I wanted to work on a lot of... If I wanted to basically work on everything, it would be a little bit more complicated. Let's see here. I'm just looking through the code here. I guess on these systems, the memory wasn't even configurable. Like, what does it do on... Holy crap. The Macintosh mappings are less clear. And the Sun one looks absolutely insane. So yeah, we basically have this entire chunk of MMU code. And it puts out letters basically saying how far it has gone. And it's also at this point that we're probably going to have to start defining a next platform. I'm not entirely sure how hard that's going to be. Let's take a look at like serial int. Yeah, I think we're going to have to define config next is, I think, the next thing we need to do. Oh god, that pun. I'm just using my vape, to be honest, and honestly, this stream calling me on it is my motivation to quit, or at least cut down significantly. So yeah, we are now basically at the doorway of I need to actually do some shit in the kernel. And that shit in the kernel is I need to add a config next. And that might really suck to add. So like, if we look at HP 300, which is like the minimum thing we can actually use. Is there any other platform that's just... Yeah, there are some platforms that are literally like just 2 files. So there isn't a whole lot of things that you need to add here. It's in the top level make file. Yeah, let's look at... Is it kconfig? Yeah, here it is. It's like config, sun, and then... I have to add all the little bits for it. Let's see here. Where, okay, so basically be config Atari, and then we go in here and we add a new next platform. It's interesting seeing all the different platforms that actually are supported. So once we do that, we'd have config next as our variable. And then we could go into serial int. And we're not actually going to set up the serial port because maybe we'll use console debug. I guess it doesn't really matter. Like I said, a lot of this code is going to get jettisoned and then rewritten. Yeah, because console int actually does a full thing with the frame buffer. Wow, that does a lot with the frame buffer. Is this all Mac specific code? Because I would assume Atari would use it. I guess not. I guess it's only for Macintosh. Interesting. So yeah, I guess we'll hook into the serial one, and then we can use the MMU print to set up the page tables the way it's expected. Yeah, serial is... I think hooking it into the serial is the easier way, because one of the first things we did on this project was we built the standalone binary for hello. Yeah, which is this. And so we basically get monitor plus offset equals code, and it was really, really simple. Because then we just need to basically do this in opcodes. I'm kind of debating if I'm going to do anything else tonight or if I'm going to call it. I don't know if I'll be streaming tomorrow. I have a real-life obligation. Yeah. Yeah, like if we look at the disassembly of put character, it really is just, we just need to get the ROM monitor address from the PROM through the NetBSD bootloader and then passed into the kernel, and then we should be able to just hook it up to kernel print put C, and then we should start getting boot messages. All right, I'm going to get a drink, and then I'm going to see if I've got any more energy in me. I'm going to note that I am actually really pleased with that progress. Like, that is a fairly large chunk of a lot of the early boot ambiguity taken care of. Once we get past the MMU, which I don't know how hard is going to be in practice, the MMU is the hard part. I also have to get the clocks running just for the absolute minimum early system. But to get all the way to start kernel, I need that. Interrupt should be trivial. I believe they're standardized in the 68040. So, given that's the case, there is a decent chance that we might be able to get to no root device fairly quickly. Like, I'm a little surprised at... I am actually kind of surprised that this part didn't take longer. I've done bare metal arm stuff, and maybe it was just because I had never done anything like it before, but I went through absolute hell even just to get to this point. So yeah. Let me see here. So BSS start, load address. I'm just wondering where... I'm pretty sure that value comes from the ROM monitor. It seems odd to me. Oh no, that would be the running program because that's the load address. Yeah, that makes perfect sense because that's where it would get initialized and put into. Loads into address 0. And then... yeah, it jumps to that. Okay, so it's a jump table. Okay, because I was just looking at how the actual code works. Because it adds an offset of 734 to the yeah, let's see here. Yeah, 734 would be put C. Yeah, I'm pretty sure when we get to DMA, it's going to be absolute hell. Like I said, I'm just kind of looking at the files right now. I do think I'm going to call it in a little bit. I don't think I want to start hacking on the kernel tonight. But I am legitimately happy with where this ended up. Right, because once we get to kernel startup, let me look at the DMA code because I actually have no familiarity with the DMA system. And I'm already scared because I'm seeing a lot of cold fire stuff. Just trying to think what else I need to be doing right now. Yeah, I am... I think tomorrow we're going to be trying to get the print messages out of the kernel successfully. At which point it definitely becomes a lot simpler. Yeah, I mean, it really is just caches an MMU until you're into the start kernel code, and then at which point it gets quite a bit harder, but we get a lot more debugging messages. Yeah, it's going to be a lot of printf debugging on this one. Early boot stuff. Let's put it like this: you're kind of in paradise if you have a serial port for early kernel. I do most of my debugging with printf. To be perfectly honest, I find it works way better than 90% of the time, unless you're dealing with memory alignment bugs. In which case, once you add your debugging printfs, the problems goes away. I've had that happen multiple times in my career. It sucks every time without fail. Yeah, I think tomorrow, if not tomorrow, then Thursday, we're going to start adding the next architecture folder. We'll add the config flags for config next, and then we'll start plumbing through the ROM monitor. All right. So I'm going to call this one here. This has actually been a really good stream. So this is your host and commander signing out, wishing you all a pleasant evening.